All right, here's another one that I recommend you watch this video for context. So there's an Astrum video that is, have scientists really discovered a huge source of anti-gravity? Answer is, I want to say no. But, you know, I recommend you watch this video first for some context of what I'm talking about and for better visuals, because the visuals that they show and the, uh, plots and stuff that they show is just way better than what I'm going to give you here, because I'm going to give you nothing. I'm not going to show anything. I'm just talking. So I recommend you watch that video, because then you will get some pretty pictures that will maybe help put together what it is that I'm talking about. And so there's the Great Attractor and Repeller, and they are powered by gravity, yet appear to act as that of a magnet. So if you look at the behavior of, we are moving towards the Great Attractor, but when you do the calculations, it appears as if we are moving too fast for what the Great Attractor should be pulling us at, right? From our estimations, we are moving towards the Great Attractor at a faster speed than expected. So we think that the Great Repeller is also pushing us. I want to say that's not the case. I think a potential reason why we are moving faster than we expect we should is when, one, we have no idea how fast we're really moving in the first place. So there's that. And then two, when we are moving towards this Great Attractor, right? But while we're moving towards the Great Attractor, we're also moving towards whatever is in our local vicinity. So if you imagine it like this, right? If you put, if we put, we'll imagine it like this. If you are running in a bus, right? You're running down the lane in a bus, and then the bus is driving on a boat, right? And then that boat is on the planet, right? And then the planet is flying around the sun, and the sun is moving through the galaxy, and the galaxy is moving through space. So if you do the calculation, right, and you say, well, how fast am I moving, right? How fast am I moving? What a great question. Anyway, and so you say, how fast am I moving? And you try and calculate your speed. So you're saying, oh, well, I'm running at this speed, plus I'm running at this speed, plus how fast I'm running, how fast the boat is moving, right? So how fast you're running in the boat, how fast the boat, how fast you're running in the bus, how fast the bus is driving on the boat, how fast the boat is moving in the water. If you add all of those up, you'll be like, well, I'm going this fast. But then you look at the sun, right, and you go, wow, I'm actually moving way faster than I thought I should be moving, right? And the reason is because that, well, yeah, you're moving that speed, but guess what? The thing that you're in is also moving. And so that thing is moving at a faster speed than you're moving. And so the planet is also flying around the Earth, right? So you have, the planet is also flying around the sun. And so you have to calculate in the speed of the Earth in your calculation. So I think a big reason why there's a discrepancy in the speed is mainly to do with that and relative velocity, and the fact that we don't necessarily have a full understanding of just how many things we're within, and how much stuff is actually pulling on us and affecting us beyond what this Great Attractor is doing. So I don't think necessarily that all this speed is coming from the Great Repeller. What the Great Repeller is just, a lack of stuff. So since there's nothing over there to pull us that way, we get pulled in the other direction. And this is the behavior of magnets, right? You have the positive and negative side. Everything seems to move in one direction, right? And then the other side is like, one side the charge goes in and the other side the charge comes out, right? And so I'm not saying that necessarily there is this invisible completion to the loop. Potentially there is. I don't think that that is necessarily outside of possibility, but what I am saying is that this gravitational behavior we are noticing on the universal scale, on the, well, maybe not the local universal scale, we'll say, because when this isn't the whole universe that's being attracted to the great attractor necessarily, but this is the local universe around us is being attracted to the great attractor. And because we are noticing this gravitational pull towards that, right, and this seeming repulsion from the great repeller, this looks, when you look at these pretty pictures, if you watch the video, it'll look a lot like magnetic field lines. And to me, this is more evidence to my point that like electromagnetism and magnetic fields are all just powered off of gravity, and everything is just particles moving through the behavior of gravity, right? It's all just built off of gravity. And when you look at the higher scale, it starts to become apparent. And so that's kind of what I'm trying to highlight here. It's kind of funny how that happens, huh? I just put a little snark there because I just think that, it seems, like I said, very apparent when you, look. So this is exactly what my theory predicts, and is my opinion, and it is, in my opinion, the proof we need to show that gravity is the cause of all the other forces. The fact that we are moving towards a point that is moving towards a larger point is more evidence to my theory of larger and larger scales of attraction and motion, right? So there is currently, we are moving towards, the great attractor, right? Or either we're moving towards this local group called Lenikia or something, and then everything is moving towards that point, but then everything that's moving towards that point is also now moving towards the great attractor. So it's collectively getting attracted here while also getting collectively attracted there. And to me, this is more evidence towards everything building at larger and larger scales, right? So what we're looking at right now is we're looking at galaxies, which are potentially atoms, right? And then these atoms are then combining into solids. And then these solids are going to build into, like they're going to go from building crystals into building rocks, and slowly build everything up, right? And we are just at such a small scale when we're looking at it that way, but we're also at such a large scale when you're looking the other way. So it's just, kind of interesting, because no matter where you look, in a sense, there's always more to go up, but also plenty to go down. And so you could also look at it as that you're already on the top. There's nowhere else to go. But that's, not too important, right? So there's a whole lot of this behavior going on all over the place at larger and at greater and greater scales, right? We have this zone of avoidance in the universe, it seems like, and you really should. There's just so many pretty pictures for this, but there's just we have maps of we're tracking the predicted flow of where these celestial bodies are going to go, and it just appears like they're all getting attracted to certain points, but as they're getting attracted to certain points, those certain points are also getting closer and closer as well. And so we just observe this greater and greater scales of attraction, and this behavior that we would expect to see on the small level is also taking place way above us as well, right, in size. And so, looking at this behavior and seeing how these things are all playing out, it just seems obvious, to me that, what I'm saying, like my theory, has merit and is observable if you just look, right? And if you just start making the comparisons, you realize just how many comparisons there are to make. This is not anti-gravity, it is just gravity. As I said, things move away from voids because there's less there to pull them that way. When the collective motion is all in one direction, it leads to an increase in speed. So the more things that are moving in a direction, the more speed is going to get, built up, because the more mass that's over there, the more it pulls on you, right? So if you start pulling everything in, right, then as you pull things in, everything, like if you imagine it like this, right, you have, this is us here, and then we have something pulling us on the side, on each side. There's nothing above us, right? And then there's something below pulling us, right? So if this thing below is pulling on us, but it's also pulling on the two things on the side of us, right? These things are going to start to get pulled down. And as these get pulled down more and more this way towards the thing that's pulling everything, then these lines that are connected to this are now going to pull on us. Like if you just do the, tangent, sine, cosine calculations and stuff, you do some Pythagorean theorem, right? As they start to get pulled down, now you're going to get pulled down with a greater force, because initially their force was kind of canceling, but now it's going to start adding to what was down here, because initially you were only getting pulled from the thing below, but then you start to get pulled with the things on both sides as well, and all of a sudden everything is just moving down together, right? Everything is pulling just down, and so your speed is going to increase because more force is being applied over time. And this is what we observe with gravity, and this is why things kind of will speed up in theory over time. I mean, it's still going to be very slow in our perspective, but in theory, the motion will increase over time. And so this also kind of gets into this whole calculating the expansion of the universe. It gets very difficult and very relative very quick, because yes, we're expanding out, but we're also getting pulled into the great attractor at the same time. So now you need to factor in your pull towards the whatever is the local group attraction point, and then you need to calculate whatever the pull is or whatever the effect is of the local group getting attracted towards the great attractor, right? And so you have all these things that you need to now calculate in, while also trying to figure out the overall expansion of the universe, right? So you're trying to figure out how fast you're moving away, while also figuring out how fast you're getting pulled in, which is, again, this kind of dichotomy thing, these, opposites of concepts. But I think that that's just a very interesting thing that we tend to find in a lot of places as well. And, it's just two sides of the same coin. It's all part of one behavior. And I think it's very interesting, and I think it's a good thing to think about. And like I said, if you just kind of look at this stuff and think about this stuff, you'll realize that I'm not really crazy for thinking this. I'm pretty confident that if anyone actually gives this some time and some thought, they will realize it has some merit. Am I saying I'm 100% correct? No, but I do think that this line of reasoning is worth looking into. And so I hope that somebody does, because as of right now, I don't really have a big following, but I'm hoping that people actually watch these videos all the way through and are following what I'm saying and are understanding what I'm, getting across here, or trying to get across here, right? And so, yeah, I think that's everything I wanted to cover in this one. I just, a lot of these videos, honestly, if you're not subscribed, if you're interested in this stuff and you're not subscribed to Asher, you probably should, because there's just, I like following like a bunch of just random channels that put out content like this, because it gives me, because I'm not actively seeking this information necessarily. Like, I'm not going and reading studies and trying to find out all of the weird mechanics of the universe. These things just kind of pop up in my recommended feed and I watch them. And I'm always like, oh, wait, that makes me think about this, right? And like I come up with a little theory to explain all of these unanswered things that we're discovering, because you know, as I've said in the past, it's just really interesting to realize just how much we still don't know. You know, I went from thinking just about everything was figured out to realizing that we are so far from getting it all, you know, figured out. And the reality is that you will never have all the answers. There's always more to learn. And so anyone that tells you that we're near the end of any field of science, they're probably not a good person to learn from, because that means that they are not a good student, and they are not very aware of what it is that they are studying. Because anyone that gets enough knowledge and enough information in a certain field will inevitably come to the realization that they do not know anything, right? Or at least they know some stuff, but they know that there's a lot that they still don't know. Anyone that is competent realizes that there is still a lot they are not aware of. And I think that that's an important lesson to learn, and it's an important thing to carry with you. Do not think you have all the answers all the time, because the reality is that you don't. And, you know, just because you think you know best doesn't mean you do. And, you know, anyone that's arguing would make the argument that I'm being a little overconfident with my theories. This is for fun. So, you know, I don't care. Yeah, so peace out.